work you've done over the last couple of lessons. Two lessons. First one was about atomic structure. The second one was about forming ions. I've gone through all of your work. I've put comments on the document, and I've added comments to the to your profiles, I think they're called. So going through, generally, pretty pleased with how everyone is getting on. The first thing was the active reading task. Now, using that, the point of that was we've done all of this stuff before. You know about the development of the model of the atom, and you know about the structure of the atom. So it's just checking for that without having to do too much writing. So you went through and you highlighted. If you do want to double check yours, I'll make sure that this document is attached to tomorrow's assignment, so you have a copy of it there to check. So this will be the mark scheme. No major problems with that. Everybody highlighted in a slightly different way, but you all certainly got the correct idea. Where we saw a big range of difference was in question 6, which was the describe in your own words what the atom looks like. Include information about the charges and masses of the subatomic particles. Lots of people didn't read that question carefully. They didn't mention the charges. They didn't mention the masses. So although the tasks I'm setting are not huge, they should take sufficient time if you do them properly. And unfortunately, lots of people didn't. So there's a diagram there to illustrate what you needed to be able to describe. So when you are looking at how you would describe the structure of an atom, and this is a very typical exam question, you want to make sure you mention the 3 particles, so electrons, protons, and neutrons. And think of a way of structuring how you would talk about that. The easiest way for me would be to start off with a nucleus. So I'd say the centre of an atom is made up of a nucleus. That nucleus consists of protons and neutrons. Protons have a mass of 1 and a positive charge. Neutrons have a mass of 1 but no charge. Round the outside of that nucleus, in shells or orbiting, are electrons. Electrons have a negative charge and negligible mass. And that was all you needed to say for that. But it was making sure you understood those key points. It is absolutely essential that you understand that diagram and you can describe that diagram to be able to move forward in this topic. So on Friday's lesson, one of the things, there might not be lots of new tasks, but it will be to make sure you go over that again and again and again and you get that sorted. Okay, moving on to the second part, the extension work. Now this was entirely optional. I'm not going to talk through this in huge amounts of detail because the answers are there. And I've commented on the people that have done it. I was really impressed to see the number of people that are doing it. There are also lots of people that should be attempting those tasks. There are bits you could do. You don't have to do all of it, but they are certainly a level of challenge that all of you could engage with and have a go at. But really impressed with those people that had a go at those tasks there. I've marked them for you. I've commented on them, but if you want to have a look at them in more detail, this will be in the assignment, so you can have a look at this page and go through the mark scheme. But well done to all the people that did the extension tasks there. Then the second lesson, when we looked at what an ion was. Now I did quite a long video on ion formation, and some people absolutely nailed this work and got it spot on. What I was quite surprised with is lots of people appeared not to have even seen the video. Now it's really important, if I've put bits of material together for you to watch, that you actually do watch it, because all of the answers to these questions were directly explained in the video, explicitly. So I typed the questions up and I put the questions together based on what I discussed in the video. So if you'd listened to the video, you could have done the questions. One of the points I'm going to mention later with general feedback is watch the video first, look at the tasks, and then maybe go back and watch parts of the video again. That will really, really help you understand what you need to do in the lesson. Or if you're sick of hearing me and you want to do something different, don't watch the video, but go to the BBC Bite Size website links I've put in, or one of the worksheets I've put in. But don't think that you can just do the questions off the top of your head straight away. You will need to be looking at the textbook, or referencing the video, or going back over the bite-sized stuff we've looked at. Okay, first question, what is an ion? Now, an important distinction we've got here is between atoms and ions. Now, an atom has an equal number of protons and electrons. So they will have the same number of protons and electrons. But that might mean that the outer shell is not full, is not complete. And that would mean it is unstable. An ion is an atom that has lost or gained electrons to become stable by getting a full outer shell. And the reason why those ions fall is, as I've said in that previous question, is to gain a full outer shell to provide stability. And these points here are actually taken from a student and they are spot on. So I've used these rather than my own mark scheme. The second point is why metals form positive ions. Now this is testing your understanding of electrons and what charge electrons have. Now metals are in groups 1, 2 and 3. So they have 1 electron in the outer shell if they're in group 1, 2 electrons in the outer shell if they're in group 2, or 3 electrons in the outer shell if they're in group 3. Now those atoms will lose those electrons from their outer shells. So a group 1 metal will lose 1 electron from its outer shell. Group 2 will lose 2 electrons from its outer shell. And group 3 will lose 3 electrons from its outer shell. That will leave all of those ions, which have now been formed, with a full outer shell. Because they've lost electrons, they've lost some of their negative charge, which means they now have more positive charge than negative charge, because they've not lost any of their positive charge. So it's unbalanced. So that leaves that metal ion with the positive charge. The opposite is the case for non-metals. Non-metals, 5 electrons, 6 electrons, 7 electrons in their outer shell. They will gain electrons to form full outer shells. So group 5 will gain 3 electrons. Group 6 will gain 2 electrons. Group 7 will gain 1 electron. That will then result in 8 electrons in the outer shell and a full, stable outer shell. But now we have extra electrons. The positive charge, the number of protons hasn't changed, but we've gained extra electrons. So that will result in a negative charge. If we've got an extra 2 electrons, we'll have a negative charge of 2. An extra 3 electrons, a negative charge of 3. So that is why we get those positive and negative ions. And again, that was shown with illustrations in the first video. So looking specifically at an example for magnesium. Magnesium is a metal. We know that because it's formed a 2+ ion. Now the reason why it forms a 2+ ion is it has 2 electrons in its outer shell. It's unstable. To gain a full outer shell, it could lose those 2 electrons or gain 6 electrons. Now, what magnesium will do is lose 2 electrons. That now results in it having 2 more protons than electrons because it's lost electrons, and it did originally have the same number of protons and electrons. So now we're left with a magnesium ion. Because it's lost 2 negative charges, it's got an overall charge of +2. And the same is the case for the next question, which is the oxygen question. So generally, that was answered really well, but you must be using the information you're given to attempt these. I feel some people are just looking at the assignment, ignoring everything else, and just cracking straight through that, writing sentencing, and that's it. That is not how you are going to progress through this, and you really need to be putting that effort in to try and get through this, because we're not here in the classroom to try and push you on. Okay, general feedback comments. Really impressed with general scientific knowledge. Presentation was generally good. Work would be even better if people read the questions carefully. So, as if you were in school. Read it once, read it again, look back into a book, read it again, and then try and answer it. Watch the videos again. There's no harm if you don't want to watch my video. finding your own YouTube video or watching one of the other links, or going back through your textbooks or going back through your exercise books. Information will be in there that can help you, but don't think that just off the top of your head you can write down the answers. Don't forget as well, we still need to see good English, so full sentences and correct basic grammar. Very important, linking in with that, you read back through your work to check for mistakes. I'm setting tasks that are not huge, there's not lots and lots of writing, but that writing needs to be of high quality, because then I'm marking it, and I don't want to be marking stuff that I feel that you've been rushing, and I want you to be spending some time on this work. And try and use the scientific terms. So if a question says, please discuss protons, electrons and neutrons, please do that. So generally, really pleased with how everyone's getting on. Virtually everyone has submitted the work. Very few people haven't submitted work, and that's with legitimate reason. So I'm really, really pleased with that. Scientific knowledge is good and it's improving. Please pick up on those points I've suggested, especially using the resources you're given, the website links, the videos, the textbook pages. Okay, so we'll be moving on next week onto some harder work and looking at what happens when these ions come together. And I look forward to seeing you soon. Thank you very much. Bye-bye.